So now, if I go anywhere around this circle, let's say I come right over here. Here is 45 degrees. There's another 45 degrees. There's an additional 45 degrees. So now I'm at 3 times 45 degrees in the positive angle measure direction from the horizontal. And I can tell you that this is a direct reflection. Probably should have drawn it up there. This is a direct reflection over the y-axis of this point. So there's some things I know in the xy plane about the coordinates of this point. First of all, it's the same vertical distance from the origin. So I know that the y coordinate to that point, based on my knowledge in algebra, is root 2 over 2. I know that the distance that I went horizontally from the origin was the same distance, the same magnitude here, but it is going to be the opposite sign. Why? Because this is the negative end of the x-axis. Here's the positive end of the x-axis. Positive end of the y-axis, negative end of the y-axis. So I know the coordinates of this point. And I could further say, let's figure out what 3 times 45, 100 and, let's see, 45, 45, 90, and another 45 is 135 degrees. So this angle measure is 135 degrees. So if I ask you, what is the cosine of 135 degrees? Well, based on the work that we just did, doesn't it have to be negative root 2 over 2? If I ask you what the sine of 135 degrees was, doesn't it have to be positive root 2 over 2? So you can take the fundamental basics of right triangle geometry, put it in the xy plane, and do straightforward reflections and come up with coordinates of points and find the sine, cosine, and therefore tangent, we'll talk about tangent in a minute, of those angle measures. So here's 45 degrees. We said we know this is negative root 2 over 2 and positive root 2 over 2. We know the coordinates of this point, negative root 2 over 2. We're in the negative x direction. And negative root 2 over 2 has to be the y coordinate to this point because we're also in the negative y direction. The coordinates of this point have to be positive root 2 over 2 because we're in the positive x direction, but still negative root 2 over 2 for the y coordinate. So we've gone all the way around the unit circle, and we have found cosine and sine values, basic trig values, for more than just 45 degrees. We have found it for 135 degrees. That's this angle measure. We have found it for this angle measure, which is 135, what is that, 225? We have found it for this angle measure, which is 360 minus 45, what is that, 315? You will learn I cannot add, subtract, multiply, or divide in my head, but we'll give it a shot. So now, if I ask you, we'll just do this really quickly here, the cosine of 45 degrees in this unit circle has to be root 2 over 2. The sine of 45 degrees, also root 2 over 2. We're at the positive end of the x-axis and the positive end of the y-axis in this quadrant. From here to here on this circle is called quadrant 1. We use a Roman numeral 1 generally for that. Here, the cosine of 135 degrees is negative root 2 over 2. And the sine of 135 degrees is positive root 2 over 2. We are in quadrant 2. We know, well, let's do it this. Here's positive x's and positive y's in quadrant 1. In quadrant 2, we have all negative x's but all positive y's. Down here is quadrant 3, where all x values are negative and all y values are negative. That's why we know the cosine of 225 degrees is negative root 2 over 2. And the sine of 225 degrees is also negative root 2 over 2. Here in quadrant 4, all x values are positive, but all y values are negative. So we know the cosine of 315 degrees is positive root 2 over 2. And the sine of 315 degrees is negative root 2 over 2. So we take a lot of what we know from algebra and bring it into what we know about trigonometry. Now, we're going to talk about tangent in a minute, but what I want to do right now is talk about quadrantal angles. Quadrantal angles come from the word quadrant, and they lie on the x and y axis. They're pretty important angle measures for us as well. The first quadrant angle right there is 90 degrees. And we know that if we are going from the origin to the surface of this circle, and that all of our radiuses are 1, we know the coordinates of this point. This point has coordinates 0, 1. Well, that's pretty interesting. How does that help us? Could you tell me, based on that information, what the sine of 90 degrees was? Could you tell me, based on that information, what the cosine of 90 degrees was? Remember what we already have in your notes. If we are in the unit circle, the x coordinate to the point is the cosine value, and the y coordinate to the point is the sine value. So there's sine and cosine of 90 degrees. When we go another 90 degrees from the horizontal, our angle measure is then 180. We know that we have a radius of 1, so we know the coordinate to this point in the plane has to be negative 1, 0. Could you tell me what the sine of 180 degrees is? Could you tell me what the cosine of 180 degrees is? Two more quadrantal angles. If I go a distance counterclockwise, which is the positive angle direction, 3/4 of the way around the circle, I have an angle measure of 270 degrees. I have still a radius in my unit circle of 1. That means the coordinates to this point have to be 0, negative 1. So I can find the sine of 270 degrees. I can find the cosine of 270 degrees. They're right there in front of me as the coordinates of that point. Additionally, I can go all the way around in one full rotation. That angle measure is either 0 degrees or 360 degrees. Either way, I'm talking about an angle whose terminal side lies right there on that axis. And I know the coordinates of that point are 1, 0. Again, my radius is still 1. So that tells me the sine of 360 degrees, which, by the way, equals the sine of 0 degrees, has to be 0. Why? Because it's the y coordinate of that point. The cosine of 360 degrees, which has to equal the cosine of 0 degrees, has to equal 1. Why? Because it's the x-coordinate of that point on the unit circle. So there are a whole bunch of exact values for you that we get directly from the unit circle.